Find dy dx using implicit differentiation. All right, 3x squared plus 3 equals, ln of 5xy squared. Well, whenever you use implicit differentiation, you're basically going to rewrite what you were originally given. 3x squared plus 3 equals ln of 5xy squared in parentheses. You're going to rewrite it, and you're going to take the derivative with respect to x of both sides. Now, in an easy sense on the left side, what that means is if you have, an x value and you take the derivative of it, you just take the derivative as normal. Bring that 2 down, multiply it there. You get 2 times 3, which is 6. That 2 becomes a 1, so x to the first, and the 3 becomes 0. Easy peasy. Well, not so much here. This is asking me to take the derivative of ln of stuff. Now, ln of x, the derivative of that would be 1 over x. But ln of something that's not x requires the chain rule. So what I'm going to do is I'm going to take the derivative of ln, the derivative of the outside, which is 1 over. Keep the stuff on the inside, so keep 5xy squared, but multiply everything by the derivative of the inside with respect to x. So let me move that over here. That's supposed to be a straight line. Didn't turn out that way. So what I have is I have 5xy squared. I'm taking the derivative of the inside with respect to x. Now what I'll do is I will use product rule. I will call you u. It's not supposed to sound like UU, but it's too late. And I will call U V. Okay. So I need to find out product rule, which is U prime V plus V prime U. So U prime is the derivative of 5x with respect to U. I'm sorry, with respect to x, which is just 5. Not bad. However, over here, I have to take the derivative of y squared. So v prime is the derivative of y squared, 2y, with respect to x, which means I attach dy dx. dy dx. So product rule, putting it all together, is going to be u prime v. So I could actually write that over here. U prime v, so 5 times y squared plus v prime u. So I'll actually write this out as 5x times 2y dy dx. V prime, you're just making sure I got everything, and I did. Let me clean this up a little bit because I have a feeling some simplifying is going to happen, and I'll probably have to get rid of all that stuff over there too. So 6x equals, this actually just goes on the top, the numerator. So 5y squared plus 10xy dy dx. dy, I keep doing that, dx, all over 5x y squared. Now what I have to do is I have to get dy dx all by itself. So what I'm going to do is I'm going to multiply both sides by 5xy squared, multiply both sides by 5xy squared. That'll allow me to get rid of this guy on the bottom. So I have 60 x squared, y squared. Did I say 60? 30 x squared, y squared equals 5y squared plus 10xy dy dx. All right, let me remove this mess over here so I can finish out the problem. I'm going to subtract 5y squared from both sides. So 30 x squared y squared minus 5y squared equals 10 x y dy dx. Last but not least, divide both sides by 10xy. Actually, not last but not least, but you know, that's fine. Divide both sides by 10xy. You all cancel out. That leaves me with 30x squared y squared minus 5y squared over 10xy equals dy dx. So let me flip the dy dx to the left. What I notice is all three of these terms have a y in common and a 5 in common. So let me pull out and divide out a 5 and a y. So my final answer is going to be 6x squared y minus, divide out a 5 and a y from that, so that leaves me with y, over, divide a 5 and a y from that, 2x. And there you have it.